Hello and welcome back. In today's video, we're going to solve a trigonometric equation that has just a little extra layer of complexity. So have a look at this equation I'm writing down right now. Back in Algebra 1, if I asked you to solve this, almost instinctually, you would know that you need to get x by itself. And to do that, the first thing you'll do is add the 5, and then in your next step, you divide both sides by 3, and voila, you're done. Now this process that we did has a name, and it's called isolating the variable. We're going to use the same process but apply it to our trig equation, and we're going to isolate the trigonometric function so that we can get our problem in a format we can work with. So let's get started. Example 2 says, solve for the given variable on the interval 0 to 2 pi. So notice that that's our standard period, or the length of one cycle for our periodic function to repeat. So that's the same as 0 to 360 degrees. There's no negative angles allowed and no crazy big angles with multiple rotations either. So just 0 to 2 pi. Now when it says the given variable, the variable we're solving for here is x. In other cases, you might see it written as theta. They both mean the same thing. They're referring to an angle measure. All right, so we're solving for the angle or angles, and they have to be between 0 and 2 pi. Now, the equation is 2 cosine x minus 1 equals 0. Like I said before, we're going to isolate the trig function. The trig function here is cosine x. So before we can even think about the unit circle, we have to isolate cosine x. Our first step, well, we'll add the 1 to both sides, and we'll get 2 cosine x equals 1. In our next step, we'll divide both sides by 2 and get cosine x equals 1/2. Now we have our trig equation in a format that we can work with. So the first thing to remember is, thinking back to your unit circle, we have our x coordinates and our y coordinates. Do you remember which matches up with which? Which one is sine and which is cosine? Hopefully, you recall that our cosine indicates our x coordinate of the terminal point, and sine represents the y coordinate of the terminal point. Really easy way to remember this, our c and s are in alphabetical order, and so are x and y, x, y, z, right? So cosine represents the x coordinate of the terminal point. So we're going to write that down right now. I'm going to put a box because this is really what I'm interested in. I need to find the angles whose x coordinate on the terminal point is 1/2. But not any 1/2. Specifically, the sign matters here. It has to be positive 1/2. So quickly, I'm going to draw a pretty large, and I encourage you also to draw a large axis, a y-axis and an x-axis. And we want x to be positive 1/2, so that rules out quadrant 2, and it rules out quadrant 3. That's where the negative x values are. So I'm going to now write 1/2 over here. If I were to imagine a unit circle, that looks about right? If from here to here is a radius, whoops. If from here to here is a radius of 1, then 1/2 will be somewhere in the middle there. Cool. So next step, let me actually make a nicer circle. You guys deserve better, okay? Y'all deserve better than that. Okay, I'm just not good at drawing circles. Forgive me. But I'm now gonna draw my angle from the origin to the terminal points where x equals 1/2. Looks like this. Then I drop the perpendicular to the x-axis. Now that's really important. You draw to the terminal point, and then we never go to the y-axis. That's a big no-no. We go to the x-axis. All right, so in both of our triangles, the x distance, or the x side, is 1/2, meaning that the y side has to be radical 3/2. Now, I didn't just make up that number. I know from studying the unit circle that if one side's 1/2, the other coordinate, or the other side length, is always radical 3/2. Same here. If I have radical 3/2, its partner is 1/2. And then if one coordinate is root 2 over 2 and it lies in the unit circle, then the other is also root 2 over 2. And that's because this indicates a 45, 45, 90 triangle. Whereas these represent, in this case, that's 60 degrees and a 30 degrees. And this one represents, whoops, gosh, it's moving all around. Anyway, this and this are both 30, 60, 90 triangles. So it is really important to recognize these coordinates and how they match up. So coming back. Now, the root 3 over 2 is the longer side. So it's across from it right here is going to be the larger angle. So it's not going to be 30, it has to be 60 degrees. And if you drew an accurate circle, then it's kind of obvious that this angle here is bigger than this little one here, which, by the way, would be 30. But as y'all know, we only want the inside angle close to the origin, and that guy has a special name. It's our reference angle. So we've made a big discovery here. Our reference angle is 60 degrees. Reference angle is not our answer. We want the actual angle measures. So measuring from 0 degrees and opening up counterclockwise, our first answer is 60 degrees. That only happens in quadrant 1 though, where the angle and the reference angle are the same. Let's see what happens with our second answer in quadrant 4. So we start at the 0 degree mark and we open all the way around counterclockwise to here. If you remember, for quadrant 4, the math is 360 degrees minus the reference angle. Our reference angle here was 60, so it's also going to be 60 in every other triangle. So 360 minus 60 leaves us with an answer of 300 degrees. And that makes sense. Think about it with me for a second. If I had opened all the way around, that would be 360 degrees. But we didn't open all the way around. We actually stopped 60 degrees early, which is why we do the 360 minus 60. Either way, our answer here is 300 degrees, and you may think we're done. But remember in the question, they asked for the variable to be solved in 0 to 2 pi. That means they want the answer in radians. Our answer currently is in degrees. So in our last step, we'll convert to radians and be done. So first, 60 degrees, you should know, is pi over 3 radians. And 300 degrees is actually a multiple of 60. So this one's a little trickier because we haven't memorized it, but I'm showing you how to go about it. So 300 is a multiple of 60 degrees. In fact, the second answer will always be a multiple of the first answer, okay? That's just, or rather, will always be a multiple of the reference angle. So you're gonna write it as blank times 60 degrees. So we need to figure out what times 60 degrees gives me 300. Or in other words, 60 degrees goes how many times into 300? The answer is 5. So if 300 is 5 times 60 degrees, that means it's 5 times pi over 3, or just 5 pi over 3. And guess what? We're done. So I hope that that approach was helpful.